So friends, let's start the numerical based on the integrations by substitution. So first of all, integrations of x square cos of x cube dx. We know the derivative of x cube is 3x square. So as x square dx present in the integration, that is why first of all we will substitute this x cube by any variable v. So let's start. Let x cube is equal to v. So differentiating both sides with respect to x, we will get d dx of x cube, that is 3x square, is equal to dv by dx. Now as we have x square dx in the integration, that is why we can write x square dx is equal to dv by 3. Okay. So what is the integration become? So integrations can be written as I equal to, instead of x square dx we will write now dv by 3. So this is dv by 3. And instead of cos of x cube we can write cos of v. So this is cos of v. Okay. So the integrations become integrations of cos of v dv by 3. Now as 1 by 3 is in the multiplicative form, so this 1 by 3 can put outside the integrations. So the integrations can be written as 1 upon 3 integration of cos of v dv. Okay. Now what is the formula of integrations of cos of v dv? We know it is sin v plus of c, where c is the integration constant. So the integration can be written as 1 upon 3 integration of cos v dv, that is sin of v plus of c, where c is the constant of integrations. Now to put the final result, we have to again reput v by x cube. So what is the answer? The answer is I is equal to 1 upon 3 sin of x cube plus of c. Okay, clear? Now come to the next question. So friends, come to the another questions, that is integrations of dx divided by x log x. We know d dx of log x is 1 by x and 1 by x present here in the integration. So that is why first of all we will substitute log x by any variable v. So let log of x by the variable v. Now differentiating both sides with respect to x. So d dx of log x is what? 1 by x. So that is why we are writing 1 by x is equal to dv by dx. Now in the integration dx by x is present. So that is why we are writing dx by x is equal to d of v. Okay. So what is the integrations now become? The integrations can be written as I is equal to, instead of this dx by x we can write dv, and 1 by log x written as 1 by v. So the integrations become integrations of dv by v. And this is the standard formula of integrations. We know integrations of dx by x as log of mod x. So integrations of dv by v can be written as log of mod of v plus of c, where c is the integration constant. So I can be written as log of mod of v plus of c. Okay. Now to put the final answers, we have to reput v by log of x. So I is equal to log of mod of log of x plus of c. Okay, clear? Now come to the next question. So friends, let's have a look on another question, that is integrations of cos of log x divided by x dx. Here also we know the derivative of log of x is 1 by x. So that is why first of all we will substitute this log of x by v. Okay. So let's write, let log of x is equal to v. Now differentiating both sides with respect to x. So d dx of log of x is 1 by x. So we are writing 1 by x is equal to dv by dx. Okay. Now as dx by x is present in the integration, so that is why we will write dx by x as dv. So this is dx by x is equal to dv. So what is the integration become? I is equal to integrations of cos of log x, that is cos of v, into dx by x, that is dv. So this is integrations of cos of v dv. Now this is the standard formula of the integrations. Integrations of cos v dv, we know it is sin v plus of c, where c is the integration constant. So I is equal to sin of v plus of c. Now to put the final answer, we have to put v as log of x. So what is the final answer? I is equal to sin of log of x plus of c. Okay, clear? Now come to the next question. So friends, come to the another questions, that is integrations of e to the power a sin inverse x divided by square root of 1 minus x squared dx. As we know, the derivative of sin inverse x is 1 divided by square root of 1 minus x squared. So that is why first of all we will substitute this sin inverse x by the new variable v. So let's start. Sin inverse of x is equal to v. Okay. Now differentiating both sides with respect to x. D dx of sin inverse x is 1 divided by square root of 1 minus of x square is equal to dv by dx. Okay. Just to differentiate both sides with respect to x. Now, as in the integration dx divided by square root of 1 minus x square present, so that is why we will write here dx divided by square root of 1 minus of x square is equal to dv. So, what is the integrations become? So, integrations is I is equal to integration of, instead of sin inverse x we will write first v. So, it is e to the power av. So, e to the power av, and instead of dx divided by square root of 1 minus x square we can write this is as dv. So, dv is here. So, the integrations become integrations of e to the power av into dv. Okay. Now, what is the integrations? The integration is simply in the standard form, that is e to the power av divided by small of a. So, I can be written as e to the power av divided by small a plus of c, where c is the integration constant. Okay. Now, to put the final answer, we have to finally put v as sin inverse of x. So, what is the answer? I is equal to 1 upon a e to the power a into sin inverse of x plus of c. Clear? Now come to the next question. So friends, come to the next question, that is integrations of sin square x divided by cos to the power 4x dx. Now to solve this numerical, in the first step, we will write sin square x by cos to the power 4x as tan square x into sec square x, because ddx of tan x can be written as sec square x dx. Okay. So in the first step, we will write sin square x by cos to the power 4x as tan square x into sec square x dx. Now, if we substitute tan x by any variable v, as we know d dx of tan x, that is derivative of tan x, is sec square x. So, that is why we first assume tan x as v. So, let tan of x as v. Now, differentiating both sides with respect to x, we will get sec square x dx as dv. Okay. Now, come to the integrations. So, what is the integration become? I is equal to, instead of tan square x we can write now it is as v square, and instead of sec square x dx we can write dv. Okay. So, this is dv. So, integrations of v square dv, it is the simple formula in the form of integrations of x to the power m dx. Okay. So, what is the answer? Integrations of v square dv, it is v cube divided by 3 plus of c, where c is the integration constant. Now, put the final results, we have to again report v by tan x. Okay. So, I equal to finally 1 upon 3 v cube, that is v is tan x. So, this is tan cube x plus of c. Okay. So, integrations of sin square x cos to the power 4x dx as 1 by 3 tan cube x plus of c. Clear? Now, come to the next question. Now, friends, come to the questions. Integrations of 1 minus of sin x divided by cube root of x plus of cos x. Here, First of all, we can substitute this x plus of cos x by any variable v, as x plus of cos x has derivative 1 minus of sin x. Okay. So, first of all, let x plus of cos of x as v. Now, differentiating both sides with respect to x. What we will get? 1 minus of sin of x is equal to dv by dx. So, 1 minus of sin of x dx can be written as dv. So, this is dv. Now, come to the integrations. So, what is the integrations become finally? Integrations of, instead of this 1 minus of sin x dx, we can write as dv. So, we are writing this is as dv whole divided by cube root of x plus cos x can be written as cube root of v, that is v to the power 1 by 3. Okay. Now, to do these integrations, we can write this is v to the power minus 1 by 3 dv, and integrations of v to the power minus 1 by 3 dv is of the form of integrations of x to the power m dx. So, applying this standard formula, we can write I is equal to v to the power 2 by 3 divided by 2 by 3 plus of c, where c is the constant of integrations. So, simplifying it, I is equal to 3 by 2 v to the power 2 by 3 plus of c. Now, to put the final answer, we have to again written v by x plus of cos x. So, the final answer is 3 by 2 x plus of cos of x whole to the power 2 by 3 plus of c. Okay, clear? Now, come to the next question. So, friend, come to the next question, that is integrations of x plus of cot x into cot square x dx. Here, first of all, we will assume x plus of cot x as v. Why? Because the derivative of x plus of cot x is 1 minus of cos x square x, and we know 1 minus of cos x square x is minus cot square x, and cot square x present in this integration. Okay. So, let x plus of cot x as v, v is the new variable. Now, differentiating both sides with respect to x, we will get 1 minus of cos x square x is equal to dv by dx. Now, this 1 minus cos x square x can be written as minus of cot square x. So, minus of cot square x is dv by dx. Now, cot square x dx can be written as minus dv. So, that is why we are writing cot square x dx is equal to minus of dv. Okay. Now, what will be the integration? The integration can be written as, instead of this x plus cot x, as we assume v, so we are writing v, and instead of this cot square x dx, we can write this is as minus of dv. So, we are writing minus of dv. Okay. So, these integrations can be written as minus of integrations of v dv. So, I is minus of integrations of v dv. Okay. Now, what is the integrations of v dv? It is v square by 2 plus of c. So, we are writing I is equal to minus of v square by 2 plus of c, where c is the integration constant. Now, to find the final answer, we have to put v as x plus of cot x. So, writing I is equal to minus of half x plus of cot of x whole square plus of c. Okay, clear? Now, come to the next question. So, friends, come to the next question, that is integrations of cos x plus x sin x whole divided by x into x plus of cos x into dx. Okay. Now, to solve these numericals, we have to first arrange the numerator in this way. Just look, I is equal to integrations of x plus of cos of x minus of x into 1 minus of sin of x whole divided by x into x plus of cos of x dx. At the denominator, we already observed that x plus cos x is one of the factor. That is why we write here first x plus of cos x. And the derivative of x plus of cos x is 1 minus sin x. So, that is why we write here 1 minus of sin x. And if we simplify this, we will get cos x plus of x sin x. Okay. Now, We can write this integration in this way: x plus of cos x whole divided by x into x plus of cos x as 1 divided by x. Okay, as x plus cos x and x plus of cos x will be cancelled out, so 1 by x will be there, minus of x into 1 minus of sin x divided by x into x plus of cos x. So x will be cancelled, so it will be 1 minus of sin x divided by x plus of cos x. So we can write this is as 1 minus of sin x divided by x plus of cos x into dx. Clear? Now we can split into two integration. So I can be written as integrations of dx by x, 1 by x into dx as dx by x, minus integrations of 1 minus sin x divided by x plus cos x into dx. So we will write it is 1 minus of sin of x divided by x plus of cos of x dx. Okay. Now look, what is the formula for integrations of dx by x? It is log of mod of x, and the derivative of x plus cos x is 1 minus of sin x. Okay. So we can write I is equal to log of mod of x plus of one integration constant, that is c1, that is integrations of dx by x is log of mod of x plus of c1 minus of integration of 1 minus sin of x divided by x plus of cos x dx. Okay. So integrations of dx by x minus integrations of 1 minus sin x by x plus cos x dx can be written as, first of all, we just simplify these integrations of dx by x as log of mod x plus of c1, where c1 is the integration constant of this integration, and we keep this integration same as. Now to solve these new integrations, we will assume x plus of cos x as v. So let x plus of cos x as v. Now differentiating both sides with respect to x. So d dx of x plus of cos x will be 1 minus of sin x. So we are writing 1 minus of sin x as dv by dx. Okay. Now as we have 1 minus of sin x into dx, so we can write 1 minus of sin x into dx as dv. Now what is the integrations become? So the final integrations is I is equal to log of mod x plus of c1 minus of integrations of, instead of this 1 minus of sin x dx, we can write now as dv. So this is dv whole divided by, instead of this x plus of cos x, we can write v. So this is v. So this is again integrations of dv by v. Okay. So I is equal to log of mod of x plus of c1 minus integrations of dv by v is again log of mod of v plus of c2. So we can write this is as log of mod of v plus of c2, where c2 is again the integration constant. Okay. Now to put the final answer, we have to substitute v by x plus of cos x. So please write I is equal to log of mod of x plus of c1 minus log of mod of x plus of cos x. So we are writing x plus of cos x plus of c2. Okay. So simplifying this, what is I? We know log m minus of log n is equal to log of m by n. So we can write this is as log of mod of x divided by x plus of cos x, and these two integration constant c1 and c2 combining we give another constant, that is c. So we can write this is as plus of c. So the integration cos x plus of x sin x divided by x into x plus of cos x has answer log of mod of x divided by x plus of cos x plus of c. Okay, clear? Now come to the next question. So friends, come to the another question, that is integrations of dx divided by 1 plus of x square into square root of tan inverse x plus of 4. Okay. We know the derivative of tan inverse x plus of 4 is 1 divided by 1 plus x square, and 1 divided by 1 plus x square is present in the integration. So first of all, we'll substitute this tan inverse x plus of 4 by the variable v. Okay. So let's write, let tan inverse of x plus of 4 is equal to v. Now differentiating both sides with respect to x. So d dx of tan inverse x is 1 divided by 1 plus of x square. The differentiation of 4 is 0. So the right hand side will be dv by dx. So d dx of tan inverse x plus of 4 give 1 divided by 1 plus of x square. As in the integration dx divided by 1 plus of x square present. So that is why we can write this is dx divided by 1 plus of x square is equal to dv. Okay. Now what is the integration become? The integration become I is equal to, instead of this dx by 1 plus of x square, we can write this is as dv, and square root of tan inverse x plus of 4 can be written as square root of v. So this is integrations of dv divided by square root of v. Okay. So what will be the integration? I is equal to integrations of v to the power minus half dv, and this is in the form of integrations of x to the power m dx. So the answer is v to the power half divided by half plus of c, that is 2 into square root of v plus of c. So I is equal to 2 into square root of v plus of c. So to give the final answer, we have to write v as tan inverse of x plus of 4. Therefore I is equal to 2 into square root of tan inverse of x plus of 4 plus of c. Okay, clear? Now come to the next question. So friends, come to the another question, that is integrations of tan cube 2x into sec of 2x dx. Okay. Now let's see how to solve this numerical. Here tan cube 2x can be written as tan square 2x into tan of 2x, and sec 2x dx is there. So that is why we will write in the first step tan cube 2x as tan square 2x into tan of 2x into sec of 2x dx. Okay. Now this tan square 2x can be written as sec square 2x minus of 1. So the integrations can be written as sec square 2x minus of 1 into sec of 2x into tan of 2x dx. Okay, clear? Now we know the derivative of sec of 2x with respect to x is 2 sec of 2x into tan of 2x dx. Okay, and as sec of 2x into tan of 2x into dx present in the integrations, so first of all we will substitute sec of 2x by the new variable b. So let sec of 2x is equal to v, where v is the new variable. Now differentiating both sides with respect to x. So d dx of sec of 2x is 2 sec of 2x into tan of 2x is equal to dv by dx. Okay. So we can write sec of 2x into tan of 2x into dx as dv by 2. So we are writing sec of 2x into tan of 2x into dx as dv by 2. Is it? Now come to the integrations. So the integrations can be written as I is equal to, instead of sec square 2x we are writing v. So this is v square minus of 1 into, instead of this sec 2x into tan 2x into dx we are writing dv by 2. So writing into dv by 2. Is it clear? So I become integration of v square minus 1 into dv by 2. Now half can be put outside of the integrations as it is in the multiplicative form. So I will be half into integrations of v square minus 1 dv. Now it is very easy. This is just we have to apply the standard formula of the integrations now. So what is the integration? I is equal to half v cube by 3 minus of v plus of c, where c is the integration constant. Okay, clear? Now to put the final answer, we have to report the value of v by sec of 2x. So writing here, so I is equal to 1 by 6 into sec cube 2x, okay, minus half of sec of 2x plus of c. So this is the answer. Okay, clear? Now come to the next question. So friends, come to another questions, that is integrations of tan of x divided by log of cos x. Here there are two functions in the integrations. One of the functions tan x, which is present at the numerator, and at the denominator log of cos x. Out of these two functions, the log of cos x is a critical functions. Okay. So first of all, we will assume this log of cos x as the new variable v. So let's write log of cos x is equal to v. Now if we differentiate both sides with respect to x, then what happens? D dx of log of cos x is equal to dv by dx. Okay, clear? Now what is d dx of log of cos x? It will be 1 by cos of x into d dx of cos x, which is minus sin x. So minus sin x is equal to dv by dx. Okay, clear? So we can write minus tan x into dx is equal to dv, more or less tan x into dx is equal to minus dv. So we can write tan x into dx is equal to minus dv. Is it clear? Now what is the integrations? I is equal to, instead of this tan x dx, we will write first of all minus dv. So minus dv is there, divided by, instead of log cos x, as we assume v, so we will write directly as v. Okay. So I will be minus of integrations of dv by v. Now integrations of dv by v can be directly written as log of mod of v. So I is equal to minus of log of mod of v plus of c, where c is the integration constant. Now to put the final answers, we have to put the value of v original, that is log of cos x. So what is I? I is equal to minus of log of mod of log of cos x plus of c. Clear? Now come to the next question.